Hello everyone. In this video, we'll discuss about some applications based on charged particle in uniform electric field. So in this, first we'll discuss about motion of a charged particle. In uniform electric field. Suppose if we are given like this, there is a uniform electric field that is directed along positive x-axis, whose magnitude is E, and in this a particle which is initially at rest, that is our first condition. The charged particle is initially at rest. The charged particle is initially at rest. That means its initial velocity is zero, and as it is having some mass as well as charge, so that electrostatic force experienced by it is QE, so that mass into acceleration, so that I can write like this. From this, acceleration will be equal to QE by EM. So if it is a positively charged particle, gets accelerated in the direction of field, accelerated in the direction of field, and if it is a negatively charged particle, accelerates in a direction opposite to the field, in a direction opposite to the field. So based on this, they will ask you what is velocity after certain instant of time, as well as displacement of the particle. Most of the questions will have like that only. So that if they asked for velocity of the particle, will use V is equal to U plus AT, as it is starting from rest. It will be U is 0, so that A is QE by M into T. And if they asked for displacement, then S will be equal to ut plus half A t square. U into T, it is 0. So half QE by M into T square. Or else we can use this equation also, V square minus U square is equal to 2AS, so that we can bring some relation between final velocity and final displacement, as we know acceleration. So here you can expect some questions like this. One simple example I'll give you like this. Find the de Broglie wavelength of the charged particle. If they ask it like this, after certain instant of time, what is de Broglie wavelength means? De Broglie wavelength formula is h by mv, so that will be equal to h by mass into qe by m into t, so that we can write like this. So as de Broglie wavelength is inversely proportional to time, as time increases, de Broglie wavelength decreases for this charged particle. So this kind of questions you can expect. Now the second case in this is, if the charged particle is moving with some initial velocity, if the charged particle is having initial velocity. So if suppose we are assuming like this, that electric field is still along positive x-axis, and the charged particle, I'm assuming it is a positively charged particle and it is having some initial velocity u, and of course its mass is m. Then that velocity v will be equal to u plus a into t, or that will be equal to u plus qe by m into t, and displacement s is equal to ut plus half qe by m into t square. So here also I can extend the same example here. If initial de Broglie wavelength is lambda naught, then find de Broglie wavelength after any instant of time. At time t, they will ask like this. Then that lambda will be equal to h by mv. I can write like this: h by m u into, I can take that u as common, so that I left with 1 plus qe by mu into t. So h by mu is nothing but lambda naught. So lambda naught by 1 plus qe by mu into t, which is less than lambda naught. So for a positively charged particle, de Broglie wavelength decreases compared to its initial value as time increases. Suppose if they gave that as a negatively charged particle, initially I assumed that as a positively charged particle. If it is a negatively charged particle, we are having electric field in this direction. And if that particle is a negatively charged particle and it is moving in the direction of field with an initial velocity u, so that what happens to our, for a negatively charged particle we are speaking, what happens to velocity vector means v is equal to u minus qe by m into t, because a negatively charged particle gets accelerated in a direction opposite to the field. So that means it will experience continuous retardation as it is moving in the direction of field, and displacement s is equal to ut minus half qe by m into t square. This is about our displacement equation. So once we know this, here we will have two examples. Of course, one is the de Broglie wavelength example, and other example is they will ask you like this: find the time after which charged particle comes to rest. That means its final velocity is becoming zero. So with the help of this equation, if I'll equate that equation to zero, as v is equal to u minus qe by m into t is equal to 0, that implies t will be equal to mu by qe. So if we use this equation, we can find the time after which that particle will come to rest. And if you find this time, in that time what is displacement, if they ask, we can use the other equation, s is equal to ut minus half at square, to find the distance traveled also. This kind of questions we can explain. And then they will ask you This question also I'll write here. Find de Broglie wavelength after certain instant of time. After time t. That will be equal to h by mv. That is equal to h by m into u minus qe by m into t. So what I can do? H by mu into 1 minus qe by mu into t, or h by mu is nothing but lambda naught by 1 minus qe by mu into t, which is less than lambda naught. As the denominator is less, it is greater than lambda naught, so that the de Broglie wavelength continuously increases with respect to time. So this kind of questions you can expect. Now the third case will be like this. If the charged particle is moving perpendicular to the field, if the charged particle is moving perpendicular to the field, suppose if the field is acting vertically downwards, this is our electric field direction. Here we are ignoring gravitational effects, and now this is our electric field direction. A charged particle is entering with an initial velocity u, and its charge is q and its mass is m. Its initial velocity is u. Let x be the width of the magnetic field region. Then we'll go this with just our analysis like in motion in a plane chapter. What is initial x component of velocity means u. There is no initial y component of velocity 0, and initial x component of acceleration is 0. Because the field is directed along y-axis, we'll have acceleration as, I'll keep minus sign because the field is in downward direction. The field is in downward direction. Now they'll ask you velocity as well as displacement equations. First I'll write displacement equation. Displacement equations along x-axis. Along x-axis we can write like this. X is equal to ux into t plus half ax into t square, and along y-axis y is equal to uy into t plus half ay into t square. So as ux is u and ax is 0, displacement along x-axis will be u into t. From the t is equal to x by u, so you can identify the time in which it will cross the electric field region. Now along y-axis, as uy is 0, y will be equal to minus half qe by m into t square. That means the particle will not move in a straight line. It will have some vertical displacement. As I am assuming that as a positively charged particle, it will experience the displacement in downward direction. If it is a negatively charged particle, definitely it will move in the upward direction. So now minus half qe by m into x square by u square. So as y is proportional to x square, this path is parabola. So what kind of path? You can expect some theory questions also. What kind of path it is following means that path is parabola. So this is from displacement equation questions. They will ask you time taken to cross and what is vertical displacement. This is vertical displacement, and they may ask you what kind of path it will follow, And sometimes they'll ask you the theory questions. If it is shifting towards downwards or upwards, then it is positive or negative. I'll give you some simple question. Just look at this example. Proton and alpha particle are there. They're having same velocity and in same field region. So of course width also same. Which will have greatest displacement if they are asked like this? That specific charge Q by M for alpha particle charge is 2q times and mass is 4m times that of the proton. That is half of q by m of proton. So if they are entering with same velocity and same field region, so definitely q by m of alpha particle it is less than that of the proton. So that displacement will be less for alpha particle. Y of alpha particle is less than y of proton. This kind of questions also they will ask by giving some particles. Here I will give you this table which is very helpful for different chapters. Proton, if it is our reference, whose charge is q and whose mass is m, then deuteron, whose charge is also q but mass will be 2m, and alpha particle, whose charge is 2q, mass will be 4m, and electron also they will give, whose charge is magnitude wise same but direction wise different, and mass will be nearly 1 by 1837 times mass of proton. So the same question if they asked were with proton and electron, q by m for electron will be greatest so that it will have greater displacement. That kind of theory questions also you can expect based on this displacement equations, very, very important. And after this, we will have this velocity equations. Velocity along x-axis. Along x-axis, velocity will be Vx is equal to Ux plus Ax into t, or as Ax is 0, Vx will be equal to U. And along y-axis, Vy will be equal to Uy plus Ay into t, or that will be equal to Uy is 0 minus Qe by m into t. They will ask you what is, as it is moving in a parabolic path, so that they will ask you this is y component and this is x component. What is angle made by that vector with horizontal? If they ask, tan alpha will be equal to by using Vy by Vx. At what angle it is leaving the field region. If they ask it like this, you will find this time with the displacement equation. You substitute that time here, you will get Vy. And once you know Vy, you can find that angle with which it is emerging from the electric field region. This kind of questions also you can expect. So this is about motion of a charged particle. We are having another simple applications like this. Just look at this application. Find number of electrons removed from an object so that its gravitational force balances with electrostatic force. So if suppose number of electrons removing means definitely it must be positively charged particle, and there is a region where electric field is vertically upwards. This positively charged particle will experience electrostatic force in upward direction, that will be QE, and gravitational force will act in downward direction. So now as they are balancing so that QE will be equal to mg, or Q is nothing but n into E, n into E, where E is charge of the electron, that is equal to m into G, or number of electrons removed, that will be mg by E into E. This is about number of electrons removed from that charged particle so that it can balance the gravitational force. So this is from one interesting experiment called Millicon oil drop experiment. Though it is not there in syllabus, but this application is an improvisation from this. In that experiment, we'll have a charged oil drop that balances the gravitational field, so that as it is a charged oil drop, so that if it is QE, mg, they will ask you some relation between radius and charge. So if I want to derive that here, QE is equal to m into g. As charged oil drop, it is spherical in nature, density into volume. So that volume of a sphere is 4/3 pi r cube into g. So from this, all other parameters are constant. So that r cube is proportional to q, or else r is proportional to q power of 1 by 3. So you can expect some comparison based questions on this by giving radius as well as charge. Okay. And we are having another interesting application with respect to friction. Suppose there is a rough horizontal surface is there. On this, a charged object is placed. This charged object is having a positive charge, and of course it is having mass m, and electric field is directed along positive x-axis, so that it will try to move in this direction. So friction will act in opposite direction as it is a rough surface. They will ask you if the system is in equilibrium, find mu. If the system is in equilibrium, find mu. So we can say like this, that frictional force as weight acts in downward direction and normal reaction will act in upward direction. So that frictional force, which is mu into n, balances with electrostatic force. So mu into normal reaction is mg, that will be equal to q into E, or mu will be equal to QE by mg. Like this, we can identify coefficient of friction of that particular surface. Now, the next application will be like this. Time period of simple pendulum. One interesting application is there. You'll have some questions based on this. Time period of simple pendulum. So, in this application, we'll discuss about how time period will be affected if we took a charged bob. So, initially we know this. If a simple pendulum is there, for small oscillations, it will perform a simple harmonic motion with the time period 2 pi square root of L by G. So now, if it is a charged bob, so we are having three different cases. We are having a positively charged bob, and in this region, electric field is directed vertically upwards first, and of course, as electric field is vertically upwards, positively charged particle will experience an acceleration in the upward direction. A is equal to QE by m, and G always acts in downward direction. So that net acceleration G effective will be equal to G minus A, which is less than G. So T is inversely proportional to square root of G effective. As denominator is decreasing, this time period will increase. T dash is greater than T, or else you can write that expression as 2 pi square root of L by G minus A. And now we are having that case B like this. For the same simple pendulum, and I am taking positive charged bob, and if the field is now acting vertically downwards, if the field is now acting vertically downwards, then we'll get that acceleration as well as G both will act in downward direction, so that G effective will be equal to G plus A, which is greater than G. As denominator is increasing, time period will decrease, so that the time period value will be 2 pi square root of L by G plus A. And the third case will be like this. If suppose we applied that field horizontally, and if that electric field, if it is applied horizontally, in that case acceleration and G both are mutually perpendicular to each other. So in this case also G effective, which is square root of G square plus A square, which is greater than G, so that T dash will be less than T. So T dash will be 2 pi square root of L by square root of G square plus A square. Here they may ask you some questions like this. If A is equal to G, then G effective will be equal to root 2G. Then T dash will be equal to 2 pi square root of L by root 2G, or else I can write this equation as 1 by 2 power of 1 by 4 into T. So time period decreases by this much factor. They may ask you this kind of questions also. If acceleration of that system horizontal is equal to acceleration due to gravity. And among with this, we are having one interesting application last in this. If you are given like this, there is a positively charged pendulum, and another charge is positive charge is placed at the pivot point. If they gave that statement like this, another positive charge is placed at the pivot point. Placed at the pivot point, and as it is a positively charged object, it will give always radially outward field. So why I am explaining this means, when we are giving a slight displacement, mg will act in downward direction, and mg cos theta will act like this, and mg sin theta will act like this, and now QE also will act along this direction only. QE into E, where Q is charge of this bob, is also acting in this direction only. Then who is responsible for the charged particle to move towards equilibrium means mg sin theta, that is our tangential force. So this field due to this charge is not affecting the tangential force, and hence time period will not change. Time period will not change because electrostatic force not affecting the tangential force, or that tangential force is our restoring force, or that SHM. So that T dash will be equal to T. This kind of questions also we can expect. So that's it for this video. I hope you all enjoyed this video. Please subscribe Progressive Physics Learning, which gives you confidence for both JEE and NEET aspirants. Have a great time.